Okay, hello and welcome. Thank you everyone for taking the time to join us today. My name is Jahan and I will be moderating today's webinar, which will be on C++ and Python for algorithmic trading. The event today will explore how Python and C++ can work together seamlessly. If you're a C++ developer or a Python developer or both, our hope is that you'll be able to walk away with plenty of valuable ideas and skills from the talks today. As before, it looks like we've had another great turnout, so I won't waste too much time before handing it over to our speakers for the talks. But before I get to that, let me just quickly go over some housekeeping. Very quickly, I'll be sharing a poll with everyone, which should only take about a minute to answer. This will help us understand who we have in the audience and help us tailor the content for today's and future webinars. Let me also just let you know about this Telegram group that we have here. So if you've been to one of our talks before, you might know already that we've got a pretty popular group on Telegram, which you can join by clicking this QR code here, following that code. I'll also post a link to it in the chat as well. So let me just do that now before I forget. So let me just get the chat up as well, and then you should see a link to that there as well. So, okay, so the group's really just a place for people to discuss algorithmic trading, statistical methods, mathematical finance, programming, implementation, and also to bounce ideas off each other for constructive feedback and discussion. If you're joining the group for the first time, please introduce yourself with some background on what you're currently working on and what you'd like to get from the group. Okay, I'll get on to the agenda and we'll very shortly invite up our speakers as well. So I'll invite Antony. First up, I'll invite Antony, who'll be talking to us about Python and C++ within the finance industry, particularly within algorithmic trading. Antony has extensive experience as a quant and developer with some well-known companies, including Barclays Capital, Citi, Citadel, and most recently, Maven Securities. He's also ran a company running systematic trading strategies on sports betting. After that, we'll have Rainer Grimm, who will be showing us various techniques to extend Python using C++. He'll be covering the C-types library and Swig and PyBind 11. Rainer is an author, trainer, and coach for C++ and Python. He's worked as a software developer and architect and is one of the most sought after C++ trainers in the industry. He runs a popular blog called Modernist C++, which is worth checking out if you haven't been there before. I'm sure we can post a link to that as well on the Telegram chat. Finally, I'll invite Richard Hickling, who will be giving us a live demo of how to use C++ to load trading data stored in the parquet file format. This C++ module will then be called from Python within a Jupyter notebook, and Richard can go into the various applications of that later. Richard is a co-founder at ProfitView and has extensive experience within the finance industry in front office quant and developer roles. He's worked at many well-known companies, including the New York Stock Exchange, Bloomberg, Deutsche Bank, Barclays Capital, Morgan Stanley, Euronext, and Bank of America. Before inviting Antony on for our first talk, let me just point you to the Q&A panel, which you should see at the bottom of your Zoom screen. We encourage you to ask plenty of questions during the talks using this panel and upvote any questions that you'd like to see answered. Okay, let me just, oh yes, so someone asked already, don't see the link. Oh yeah, I think I accidentally didn't send it to everyone. Okay, let me send it again. Yeah, so can you see that link now? I think everyone should see it now. Okay, great. Yeah, so let me hand it over to Antony now. So he'll take us away for the first talk.
Thanks, Jahan. Let me just bring up the presentation and I'll share it. Okay. So yeah, I wanted to give some people some concrete examples of how we're using C++ and Python together in industry. And I mean, the first thing I'll start on talking about is build system integration. And actually, it might not sound like the sexiest thing to talk about, but actually, I would say it's one of the most important ways that we use it. Let me first, right. So the first thing I'll talk about is, I mean, obviously we've put an example together on GitHub, which everyone can take a look at. One of the ways that we're using Python there is we're using a package management system called Conan. So C++ isn't nearly as nice to get working with as Python is, primarily because there isn't a standard package management system. There's now 3 or 4. There didn't used to be any a number of years ago. And this is one of the things that gets discussed at the standards committee a lot, particularly in the context of things like Rust, which have come along with standard package management and build systems. Using something like Conan or VCPack or one of the other package managers gets you access to a whole load of packages, libraries that you can use in your application. I think, you know, you don't want to be writing things from scratch as much as possible. Where there's good quality libraries, you want to be using those. And C++ is much more complicated than other languages in that regard, because you could be building across a whole range of architectures, operating systems, instruction sets, and configurations. And then you might be able to add on top of that you might also be building with a whole load of different compiler definitions. We'll look at some examples of that later when we look at the application and how we do code coverage. But that leads to a situation where you've potentially got exponential, a combinatorial explosion in the way that you can build your package. Conan solves that problem really nicely by defining via a Python file, what's called the Conan file.py, a set of instructions that tells Conan how to generate the package so that it works with any build system that you're going to use C++ with. And as we already mentioned, C++ got a whole load of build systems, and so that's a big win in terms of usability. Code generation. So when you start working on code bases that are millions of lines big, and there are lots of them out there, you're going to find that you're going to need to use practices that scale. So I think a good example that I'll give you from the trading industry is when you're working and you're communicating with exchanges. If you think about a trading company that connects to exchanges, there's hundreds of exchanges. If you add crypto exchanges to that, then there's many, many more. Each of these exchanges, they work by sending a load of binary data across a wire, which you interpret. You get that binary data, you have to try and make some sense of that. And the way that you make sense of that is by using a protocol. A protocol is basically a set of instructions defining how that data is laid out. Now, some exchanges, for example, if you're working on something like CME, which is one of the biggest exchanges in the world, they have a data format called SBE, and SBE is quite nice to work with because it provides XML files that define what those message structures look like. But lots of them don't. Lots of them give you PDF files. Lots of them, don't give you a very developer-friendly way of defining your message classes. So what people do is they end up handcrafting their messages. Now, that's okay when you're communicating on 1 or 2 exchanges, but as soon as you're suddenly scaling out and your trading company is working on 20 or 30 exchanges, that begins to become problematic. So the way that we solve that in industry, or certainly the way that I've seen it solved in industry, is we use Python as a way of getting access to libraries that can extract data from PDFs. We can then extract that data. We extract that into some intermediate format, and then using that intermediate format, we then pass that on to another step in the process, which generates the messages for us. So doing that solves a number of problems. One of the biggest problems is that if you're trading on an exchange, over time, that exchange is going to change their functionality. The way that they do that is they release new versions of the protocol. That generally means either adding new fields or moving things around. And so you end up in a situation where you're not just supporting that protocol, you're supporting multiple versions of that protocol. So perhaps you put some code in there and you try and detect which version of the protocol you're working with, and how to, which version to interpret the bytes on the data as. Now that solves one problem, but the bigger problem you're going to have is you're not just trying to interpret the data that you're collecting today. The way that trading companies work is when they're connected to exchanges, they capture all of the network traffic that they're seeing. So that's called a packet capture. So they capture that data and they record it. And part of the reason they do that is because, the time that you write the protocol, you interpret the messages, you build up a view of the market data. You might build some view of that market data based on the messages that you're interested in. But what's going to happen is perhaps you don't support all functionality on all exchanges. If you're supporting 200 exchanges, one of the things that you're going to see is that they all differ radically in terms of their implementation. And so you're trying to find some common subset of the functionality that you support. That then means as you add new features, you might have recorded that data, you might have extracted the view of the market data from that you're interested in. That then gets piped around to everyone else in your company who can use that to build their trading strategies. But now you find that suddenly you want to support auctions, and previously you weren't extracting auction messages and listening to those. So now you have to go back against that recorded data and you need to replay. And so using those recordings, you need to support multiple versions side by side. Straight away we're talking about exponentially scaling the amount of code that we have to store. And so wherever possible, we want to try and automate those by using code generation. Another use case that I've seen is serialization. If you have a 10 million line code base, writing serialization by hand is not just painful, it's probably particularly error prone. You only have to add a new message to the header, a new piece of data, and forget to update those methods, and straight away you've got a bug. And you only need to run into those bugs a few times before you're suddenly going to realize that you're losing a huge amount of time to diagnosing the same problem happening again and again. Well, one of the ways that companies deal with that is they use code generation. So they, with tools like Clang, we'll talk a little bit about libclang, which is a Python wrapper to the Clang compiler. You can actually get access to the C++ abstract data representation, and then you can build code which generates automatically C++ serialization functions for you, which you then compile in. And doing that, that you're automatically going to ensure that your serialization is always up to date with the representation of your code in the header files. So Python wrappers to C++ libraries, it's really common that in trading houses, you've got some C++ code. I mean, very often if you're working in a quant group will have an analytics library built in C++ that's using all sorts of high performance computing components. It might be doing multi-threading to distribute the work, which you can't do in Python because of the global interpreter lock. You might also be doing things like accessing different instruction sets. So you might be using SIMD or AVX instructions, which allow you to do data parallel instructions. So now you then want to access that functionality in Python. So then you need to write bindings. And so again, if you've already wrote code that can walk the abstract syntax tree in C++ and can look at the structure of your code, and you can generate serialization, why not auto-generate it? That said, I've seen a lot of places write it by hand. Richard will talk to you a little bit about that, but it can be done. But the larger your code base gets, that's more code that you're maintaining by hand. And finally, test suite integration. So if you have your whole C++ test running for your test suite, you probably want to tie your Python tests into that. We're going to look at some other use cases, things like domain-specific languages that you might have, which you might expose via Python, again, by wrapping the libraries that you have for that. I think integrating that with the test suite gives you one command that you run, and it's going to run all of those unit tests for C++, for Python, and even for other use cases like domain-specific languages that you have. And again, another use case around test suite integration is one of code coverage. We'll touch on this at the end because we've actually provided an example of this working. But for example, if you have C++ and you have Python code that's using unit tests, you always want to be using code coverage wherever you can, because that gives you an idea of the kind of confidence level that you can have in your tests in terms of how much code they cover. And ideally, you want to provide that for all languages. Okay, so another common use case for using Python and C++ together in trading companies is data pipelines. So some of the big hedge funds that I mean, one of the things that they do is they write a lot of web scrapers. They scrape a huge amount of information from websites online, and they build things like economic data. They do things like forecasting, how many people are going to, certain coffee shops in central London, what's the footfall. They use all sorts of self-generated economic data like that, which helps them to make forecasts, which then get used by their trading strategies. Of course, if you're scraping data like that, it's not always going to be in a usable form. So one of the things you need to do is, you need to get that data and then you need to cross-sanitize it. So that means effectively making sense of your data. Is it correct? Is there inconsistencies in there? So you might look for, huge outliers in your data set. If you've got a huge amount of data, gigabytes or terabytes of data, you can't make those kind of decisions by hand. So you need to build in some sanitizers that can use some statistical information to try and pick out outliers and try and work out where the errors are in the data sets that you're using. Once you have those data sets, they're not always going to be in a usable fashion. So for example, if you're recording, L3 market data, which is, is recording data from an exchange on a tick to tick as orders come in, and you've got all the levels of the order book, that's not necessarily what your researchers are going to want to use. They might just be interested in top of book. That's going to look a lot more like when you look at Google Finance or, a kind of conventional stock chart, and you see one line, not a huge range of values on either side. And so that tends to be the view that a lot of researchers are going to use of that market. But if you're recording data, you're recording PCAPs and capturing market data from L3 exchange data, you have to transform that and produce an L1 view for people to then use that. And finally, data stores. So you've done the work of transforming that data. You then want to write it into databases, and so perhaps you're using things like KDB, or there's a whole number of different databases you could look at. Python has a lot of bindings to this, as does C++. You'll look at your use case, but quite often where you've got really heavy lifting and transformation of data to do, you're going to want to use C++, you're going to use threading, and you're really going to want to utilize all of the resources of your machine. Another thing you often want to do with exchange data is you want to simulate data. So one of the things that you'll find is when you're working on exchanges, if you're working in a UAT environment, which effectively means it's a pretend environment that anyone who's participating can try things out, and it's not the real production environment. Well, often those environments can be quite hard to test on, and part of the reason they can be quite hard to test on is because there's often not a lot of trades or data happening on those. And so in that case, it's very common to build in simulated data and then to run that through your current data pipeline so that it looks like you're getting actual live data. And that allows you to do testing and testing cases even where you're not ready to go live with that testing. And then, of course, at the end of this, people are probably going to be consuming this data. They're going to be using Python because Python is the tool for research, really. They're going to be using IPython notebook. They're going to be visualizing that data, and they're going to want to draw conclusions from that data. And Python is a much stronger language for that aspect than C++ is. So domain-specific languages. It's surprising that this still happens in this day and age, given how many languages we have, but it does. Certainly, I think every investment bank I've worked at has domain-specific languages. Sometimes I've seen languages for describing the payoff of complex trades, which allows traders to write logic that prices their trades without having to go to the quant group and get them to implement something, custom quantitative, analysis in C++. That normally means writing bindings in C++ and Python. The main advantage, obviously, of binding in Python is you're then going to get kind of REPL functionality, so you can test it very easily. You can put it into IPython notebook. You can drive it from Python, but underneath the hood, it's actually going to be driving your custom language. Again, we talked about build systems. You want all of your unit tests and all of your testing ideally runnable from one command, and so we want to tie that into the build system. Python, you can probably do this through C++, but Python is going to be an easier interface to doing that. And if your build system already supports running of Python unit testing, then that's not going to take long to do because you've already done the hard work. And finally, it's really common when you have domain-specific languages to want to provide Excel as an interface. Again, often it's going to be your traders who are using it, and they're used to using Excel. And so, if you think about Python, you've got things like PyExcel. You've got numerous toolkits which allow you to run things in Python, but to provide interfaces to those in spreadsheets to the traders. Okay, and yeah, I think we've already touched on that last point. And then finally, high performance components in Python. Well, Python already provides some very high performance components. If you're using something like NumPy, it's quite likely going to be built against something like the Intel Maths kernel library, which is going to do vectorization for you, but that doesn't mean that it's going to have all the functionality you want. So, as I already mentioned, every quant group I've worked with will provide bindings for Python, in part for their quants, and also nowadays in part for their traders. I think more and more I see traders using Python, in industry. That reminds me of being at one investment bank and having the traders come to us and asking us to teach them Python, because it was very clear that their job was moving away from one where they wanted to drive spreadsheets in Excel that had lots of functionality embedded in, to one where they wanted to drive their code via Python, because that enabled them with the ability to unit test it as well and ensure that the numbers they were generating were correct. Another big use case for high performance components when you're binding C++ to Python is messaging systems. So, if you think about a hedge fund, we've already talked about, you're going to be connecting to exchanges, getting this market data. To get data, market data, you're going to be co-located in an exchange, generally, if you care about performance and speed. So let's say you've got your high performance application running that's, processing terabytes of data a second. What you probably don't want to do is embed your trading logic into that application in case it goes down. So the way that most systems will work is they'll use a messaging system. That means that they can then use UDP to pipe that data around to the rest of the, any other computer in the app, in the company that needs to use that data. If you really care about performance and you want to run that program on the same process, a lot of messages support RPC, which is remote communication for processes, where they use a shared memory system. But to do this, you're going to need a library that provides this functionality. You're obviously going to write this in C++ because you care about speed, but you're also going to want access to this market data and other features that are being exported by this, and so you're going to need bindings for that. We already touched on NumPy using the Intel Maths kernel library. Another common use case that I've seen in investment banks is most investment banks use a high-performance computing library called NAG, which is Numerical Algorithms Group. And that's a library that provides a load of very high-quality optimization and mathematical routines in a library that also takes care of, which type of instruction set you're using and are they vectorized. So again, you often see these kind of libraries being exposed by Python so that traders can price things in their spreadsheets or Python notebooks. And again, as always, we always want to be building all of this stuff into our existing build system. Again, we've already talked about this. That gives you the ability to test and run all your tests from one place, which, if you want to have any confidence in what you're doing, that's absolutely critical. And then finally, we'll just talk a little bit about the example. We've already touched on Conan. So the example that we've provided, what we've tried to do is just provide a little example using Conan, CMake, some C++ and Python, just to show how you can mix all of these things in one project. We've used Conan, obviously running in Python, which will connect pull down dependencies, build them as part of your build system. Richard is going to talk a little bit about a C++ example that he's done, which is providing a wrapper to some C++ abstractions that then enable it for use via PyBind 11. Now, another thing that we talk about, I think that's worth mentioning, is that if you have a very complicated build system, you may well be using Python in lots of different ways. Now, whenever you're using Python, you want to make sure, just like with C++ and when we're using Conan, you want to make sure that Python has all of its dependencies. And so the way that we do that is we tend to use virtual environments, which isolate for a specific task all of the dependencies that are needed for that task. So in this example, we've provided some code that will build a virtual environment in your build tree. And so it's just like any other intermediate output that's part of your build that can be blown away. But as you're building and as you execute any Python processes within your build, each specific Python process can pull down any dependencies it needs without knowing that either the user's got to have those installed on the system Python, or they're going to interfere with any other dependencies that are in the version of Python that the build finds when it's trying to run. So finally, I've actually got that last point wrong. That should say we're using code coverage, which was what I was going to talk about. So in the example, the way that we've demonstrated Python in the build here is we've built a module in CMake which switches on code coverage. And so the way that code coverage works is your compiler inserts some extra information into the build, which then when you run your unit tests will get collected so that you can then run another process. In this case, it's a process called lcov, which will generate a HTML report for you on where has been touched when you run the program. Ideally, it's a coverage report. And so that can be quite slow on big code bases. And so actually what we've done is we're not just using lcov, we're using a Python library called fastcov. And so fastcov is wrote in Python. It uses MPI, so it runs multiple processes, and it looks at the build, it sees how many object files there are, it looks for each object file, it tries to find a file of data talking about, what's the coverage within that unit. As I say, that's slow, so fastcov runs a whole load of those in parallel in order to speed up the build, and it does that using Python in the build. And so we've isolated all of the dependencies for that within a virtual environment. And that's it. I think we'll probably talk about this a bit more later, but I'll stop sharing there.
We've already had quite a few questions on that already, so
fantastic. I'll try and answer those now while Rayna's talking.
We could also cover them at the end, I suppose, just in case. I suppose for the recording, I was just thinking,
let's do that.
Yeah, because the recording, that way people can see the questions. I don't know if there's any easy way for the people to see it otherwise. Okay, let me just launch the poll here as well. Please get a chance to answer that if you can. But yeah, on to Antony, or sorry, on to Rainer now. So on to you now. Thanks.
Should I start? By the way, I assume you can see my screen?
Yeah. Yeah,
okay, fine. So let me start. I'm happy to be here. And first of all, I have to admit I'm a Python and a C++ trainer. I give Python classes since 24. I started with a 1 version. You see, I'm pretty old in C++ and Python anyway. And what I want to do today is to give you an overview about communication between Python and C/C++. I will do it in different ways. I will start natively and then I will end in the way you should do it using PyBind 11. Okay, let me start. First of all, what's the difference between extending and embedding? Essentially, it's the opposite. You see, extending means you start with Python, you convert the data types into a C/C++ representation, you use the data types in C/C++, and then you convert them back. This is extending. Embedding is the other way around. You start with Python, you convert your data types in C, C++. Sorry, other way around. You convert the data types from C, C++ into Python. You do with the things something in Python, and then you convert it back to C, C++. So it's just opposite. My talk will mainly be about extending. I will say a few words about embedding, but extending is the more typical thing, which means you call from Python C, C++ functionality. First of all, why do you want to do that? Antony already mentioned it. First reason, of course, try, don't repeat yourself. The functionality is available in a DLL on a shared object. Why should you implement it once more in Python? Second point, performance issues. You identified a bottleneck in your application, and you say, okay, let's try it out in C, C++, and now it is faster, and now you can use it directly from Python. Then Python has an issue regarding concurrency. We have the GIL, global interpreter lock. This means at one point in time, only one thread can be active. This is the GIL. This is not so good. And finally, which I think will show Richard later, meaning you maybe read your data with C, C++, and then you play with them in Python. You can use it in a Jupyter notebook or something like that. This is an extremely easy way to play with your data, analyze it, get a feeling how the data looks like. So there are a few reasons for doing that. How can we do that? First, let me talk about extending. I will be too fast anyway. I will become a little bit slower. Extending. First of all, we need a shared library. I don't explain how we get a shared library, so just assume this is a shared library. It has, of course, a program called Hello World, and I start simply with C. And now I want to use this stuff from Python. I will do it in different ways. The first way is to use C types. C types is a built-in library into Python, is one of the more than 300 libraries in Python. Here's just a Linux command line. It also works with Windows. And this means you can directly load a SO, meaning shared object. This is all. I have a shared object. I load it with C types, which is part of Python. Then I can invoke this function hello world, which is part of the module hello world. And now you see the output hello world, and this is the length of the output. This was easy, right? It's just built into Python. But we can do more. We can load the libc. Now I invoke from libc the time function, and this gives me back, I assume this, the seconds since epoch, since the 1st January 1970. But I can use directly cprintf from Python. You see? Hello world, this is a binary string. And here I do it with format specifiers. And the issue is, for other data types, such as ints and strings, I have to specify which kind of data type this is. And this, of course, is a double. Therefore, I can use printf from C, and here is it. There's a nicer way to do it. You can specify a function prototype. You say here, these are the arguments I get. It's a C string, it's a C string, it's an int, it's a double. Here are they: C string, int, and double. And now this sentence is displayed. But I can do more. I can use a C function, string char, which gives me back the position of the W. But it assumes as return type an int, and this is not what I want to have. Therefore, I have to specify, no, this is not an int, this is a C string. And now I got back the result world. So the string starting with W. And now, of course, I can do both. I specify the arguments and I specify the return type. And this is what I get. This is just built into Python. I only need a shared object or DLL when you want to use Windows. Okay, how does this work? Let's try it out. Now I start extremely natively. So I do it all by manually. First of all, I need a shared library. We have it. This is easy. And here's the idea. This is what you have to do. It's only an overview because I have no time to dive into the details. I first include the Python API. You see, this is a C or C++ file anyway. Then I declare my C function. This is the C function I want to invoke. And you see, this C function gets PyObject. This is the basic type, which is always used when you call from Python into C or C++. Then I define the method table. These are all the methods I want to invoke. Here's the definition of this function. This was the declaration, this is the definition. And here, finally, it's the initialization. This is, let me put it differently. When you say from Python, import hello world, this function is invoked, and this returns to your module, which you now can use. So this is the structure. And when you do that, you need additionally a build file. This is from disutils, also one of the more than 300 libraries in Python. And this is the a minimal structure. What this needs at least is I want to have an extension module, which means a shared object or DLL, and it needs a name. Hello world, this is the name of the module. And you see, this is my extension, and it consists of this file here, hello world.c. And this file as an entire file is called setup.py or py. And this is the way I build it. I say Python 3.6 setup.py. This is this file here. And then I say install this shared library locally, or you can also say in place. Then this build process is started with a pretty long command line. And this is all. Now I have a shared library. You see it here. You see, this is the naming convention. Hello world. This is the name of my shared library. And here it ends with SO. And now I can open the Python REPL, can say import hello world. Here's my hello world. I can look inside the module. You see, this is what's inside the module, in particular, this function hello world. And now I can invoke it. And this is boring. It just says hello world. So this is the native approach. But honestly, you don't want to do it because this is too laborious. What should we do? In the past, we used Swig. I said in the past, I think Swig is from around 1995, 1996, so it's pretty old. Swig stands for Simplified Wrapper and Interface Generator. And this generates you an interface, but not only to Python, it generates you an interface to different languages. C#, D, Java, JavaScript, Perl, and of course, Python. So let me do that. First, I have to specify the interface. Here's the interface definition. Hello.e, it's the name of the file. This is what is exported. And this is the name of my module. You see, hello world. Okay, how does it work? Extremely simple. I say swig minus Python hello world.e. And this generates two files, a low-level C file and a high-level Python file. This is what I import. When I say import hello world, this stuff would be imported, which uses this wrapper, and under hood invokes my my C functionality. By the way, I looked a few minutes ago into this file. This has more than around 4,000 lines of code. So it's pretty big. Okay, but I don't care. It's auto-generated. This is, you know it from before, my .h file, my .c file. And now I have to do the same I can literally use the same setup.py file I used before. I set Python 3.6 setup.py and so on and so on and so on. And finally, I can say import hello world, dear hello world. You see now there are a few special attributes here, Swig, which are due to Swig, to this interface generator. But of course, there's also here my hello world. And now I can invoke it. Okay. Honestly, this was only for pedagogical reasons. I don't suggest that you go this way. This is way too low level, way too complicated, way too error prone. What you should do is use PyBind 11. PyBind 11, the 11 stands for seamless operation between C++ 11 and Python. By the way, they say C++ 11, but essentially you can use C++ 17, but only this is part of the name. It's fully implemented in header files, so it's pretty easy to use. It's based on Boost Python. Maybe you don't know it, but Boost was created with a Python project from Dave Abrahams. So it's based on Boost Python, but without the dependencies. This is the main difference between Boost Python. And what you can do is both. You can extend Python and you can embed Python. Meaning you can call from Python C++ and you can call from C++ Python, both ways. Let me show you a first example using PyBind 11. And this is all, you see, this is all. I of course installed PyBind 11. I created here a small function, add, and this is my binding. So once more, this is the Python binding here from PyBind 11. This is my module. The name of my module now is function, and this is the object, my module itself. Then I bind a definition to it, and you see this is the name I would use from Python, and this is matched or mapped to this C function name, and this is the documentation string, which I do, but anyway. And this is all. This is all what I have to do to invoke a C function from Python. But of course, this is boring. Let's do a little bit more interesting things. First of all, there's the convention. You use PyBind 11 always with py. It's just a convention. And here are a few very interesting things. You can use keyword arguments. I'm not sure if you know what this means. When in Python, you have a function which has, this is not a Python function. When you have a function in Python, which takes two arguments, one is called I and one is called G. You can invoke them by using the function arguments names. This is something we cannot do in C++. We want to do it, but we cannot do it. Additionally, you can also provide default values. You see, 2011. But it's even more interesting. What you can do is now, you can from Python, once more, this is the Python interface. It's called sum, and this calls this function here. This is the C function. This C function, count carefully, takes two arguments. This takes three arguments. What does this mean? You can from Python call a C or C++ function, a C++ function, it's overloading, which takes two or three arguments. And you know what's interesting here? Python does not support this feature, but now you have it using PyBind 11. You have function you have overloading, to make it short. In Python, you don't have overloading. Why not? Because each entity in Python is a key in a dictionary, essentially. There can only be one key, only one function name. So this is very interesting. It makes Python even more powerful, PyBind 11. And the second point is here are two attributes. It's not so interesting. Let me show it to you. So usually you should not do it, but I do it here. From function import star. I import from the module function all the stuff unqualified. Okay, now I can say add 2011. Here now I use them by specifying the name of the arguments. I and J, have a look here. I and J. So this works. And I can also do it in the other way, because now I use keyword arguments and not positional arguments. Here I use all the defaults. And this is interesting. You see, now in Python, I can invoke some with 2 or 3 arguments. Once more, this is not possible in Python, because Python does not support overloading, meaning there's only one sum. And of course, I can use year in language. Okay, let me continue here. A little bit more sophisticated, but it's not really sophisticated. Let's do a little bit of OO. Here's a small class, human being. It has a constructor taking a const string ref, function get name, constant returning the name, and an attribute name. And now I want to use this stuff from Python. And this is the entire glue code. This is extremely convenient. I define a module human, and in this module, I define, or I make the binding for a class, for C++ class. The name of the C++ class is human being. You see it here, human being. And I use the same name on the Python side. Here, I define, I assume this irritates you a little bit. This is a special way to use a constructor. Here, I defined a constructor in Python, which calls the constructor implicitly in C++. You see, const string ref. And finally, I define a member function, or in Python, I should say method, which calls the member function get name on in C++. Okay, let's try it out. A few additional things, which is extremely nice. I'm not sure how good you are in Python, but in Python, we have a kind of an output operator. And it's called operator overloading. And this is the convention. You have to implement for a class __wrapper __. And because this is so terrible to say, we say in Python dunder wrapper, which means double underscore. It's just a slogan or abbreviation. And you see what? I define the member function, the special member function, dunder wrapper, which maps to a lambda. Honestly, this looks for me extremely convenient. And now I can display instances of human being in a readable way. This is the output operator in Python. There are 2 of them. This is the native one, dunder wrapper. I can define attributes, read write, family name maps to this attribute here. And what I do here, you see what I do here? This is inheritance. I have a class human being, and I derive woman from human being. And for both, I specified the constructor. This is how you say encapsulate inheritance. Okay, let's try it out. First of all, once more, I import the module in an unqualified way. Then I instantiate one woman, which I call Beatrix, and I give the instance is called Bea. And now you see when I say Bea, human being Beatrix is displayed. Why? Because here's why. I implemented dunder wrapper. And you see human being and the name of her. Then I can look inside Bea, inside the object. Here is a kind of the keys of the object. And you see this object has a few more keys. It has a family name, it has a gender, and it has a member function get name. a little bit more than you saw in the slides before. And now let me play with it. The family name is Grimm. Of course, it's my wife. And her name is Beatrix. Her gender, and you see what? This is a function, and therefore I don't call it with the with parentheses. It gives me back the function object. But when I use it as a callable, I get back the gender, which is female. And finally, I say print bear, which in this case displays the name in a nicer way, Grimm Beatrix. I should have said it. I also overload Dante string, which is the human readable output operator in Python. Okay. Once more, this was only an introduction. Let me say a few words about embedding, and then I'm done. I could also use PyBind 11 for embedding. It would be even easier, but I did it the hard way because you should see how it's done under the hood. What does embedding mean? You call from C, C++, Python. You may wonder, why should we do that? In my previous company, we did that for the following reason. What we did was the following. We had a big Qt C++ application, which did car crash simulation with big data sets. And what we did was the following. When the C++ GUI was running and you used all the buttons to play with your car data set and see what's happening and analyze your car crash, we serialized the call into Python calls. So we played with it and we wrote back Python statements. After that, we could use these Python statements to control our C++ application. We could use that to make automatic tests, GUI tests essentially, to load different data sets and to remotely trigger GUI operations, because we serialized our C++ instruction into Python statements. I don't know how to say it differently, but this was extremely powerful. So sometimes you want to do this stuff. Okay, so what is, how can you do that? First of all, you can execute a string from C, C++. This is only C. This is what you have to do. You have to initialize the interpreter, you have to shut it down, and this is what is done. These are Python statements. You import the module time, and then you display the current time. And this is what you get. It's not so interesting, you see, but it essentially works. So you can just execute in Python in string, which stands for Python string, no Python statements. Here I have all of the stuff in a module, showtime.py. And therefore I can also execute a module. And this is how I do it. I say initialize, finalize, then I load this module, and then I just let it run. You see, this is, by the way, the convention. All the Python API starts with py. And now to a little bit more sophisticated thing. And then I'm done. You can even execute an entire function. Have a look, I have a function which defines I have a module which defines 3 functions. A function for calculating the faculty, the sum of 2 numbers, and the product of 2 numbers. It first displays in Python some message. So what the function is doing, calculating the faculty, calculating the sum, calculating the product using Python's format strings. And then it returns its result. But the result is returned to C. How does it work? This is how it works. This is a C function. Of course, it's executable. I load this module myMass. You see it here, myMass. And then I say, let's execute the function faculty with the argument 10. Then Python says, return a faculty of 10. You see, this is what Python says. and the result is transferred back to C, and now C says, this is the result of the function called in Python, the faculty of 10. And here I invoke this other function, sum, with 2011. And here I invoke product with also 2011. And finally, here's the idea how this works. This is once more a C file. First, this C file has to read the command line. Then you have to extend this Python search path for modules so that you find your modules. Then you have to import the module, this module here, my master py. Then you pass the function arguments because you have to convert them from C to Python. Then you call the Python functionality, and then you convert the values back to C, and you display the result in C. When you really want to see this program here, I can send it to you, but this is only the overview of the program. And then you see this is a 30-40 liner, which does essentially this 6 steps. Okay, this was it. I talked about extending and embedding Python. I have to say, in most cases, extending is your use case. I think 80% of all use cases are extended. But you can also do embedding, do it the other way around. And I explained you a short story about what we did in our past. Essentially serializing a C++ application. I don't know if this is the right term, but I think you know what I mean. Okay, I'm done.
We have plenty of questions, which we'll get to at the end. But yeah, no, that was really interesting. Let me just quickly remind everyone again, if you haven't completed the poll, would you mind just doing that, please? And then I'll probably close the poll quite shortly. And just one other reminder, if you haven't joined the Telegram group already, please, you can use that QR code. You can join it that way. I've also got a link in the chat as well. I think the first link I sent didn't quite work. I may have used this website, which I think you need a paid subscription for or something, and my free account ran out or something. So you can join it using that link. Okay, so I'll hand it over to Richard now. And after that, we'll get to the questions. Okay, over to you now, Richard. I think you're on mute still.
Yeah, I was on mute. I was trying to find the mute button. Okay, great. Thank you very much, Antony and Rhino. It was really interesting. I think I learned a lot there myself. Well, what I'm going to do is think, or sort of, it's a slightly contrived example, but one which must be part of what would be implemented in a large trading organization. We're interested here in algo trading. In the organizations which do algo trading, they have to backtest. It's not going to give them everything they need to validate an algorithm, but it's an essential part of it. And you can imagine in a big organization, which is in an arms race with competitors, they are making frequent changes to their algos, and they want to deploy them quickly with as low risk as they can. So they want to get the algos back tested. They want to back test on as much data as they can. They want to test against all the symbols that they are going to trade against, and they want to do it as often as they can. In fact, it would be reasonable to place the backtesting in their continuous integration. However, the problem with this is that especially if you're dealing with derivatives, non-linear derivatives, you have to value in your backtesting, and that can be prohibitively slow if done in pure Python. Now, of course, it wouldn't be done in pure Python, but even if it's done via Python, all the Python calls are potential slowdowns. So these are places where you would look at least to optimize, and quite likely in C++. So let me, I'll share my screen shortly. What I'm going to show you is just part of this, which is that the way you backtest is to save down trading data. And when you're talking about in a liquid market, and if your algos rely on full book, it can be up to terabytes of data. And if you're looking back in 3 years or 4 years to run your test, it's a very significant amount of data. It's so significant that your memory on your machine is probably going to be exhausted, and so the data formats and storage formats must take this into account. The one we'll look at is very popular for financial data, and that's parquet. Parquet, for instance, its structure is to, I'll share my screen now and show you what I mean. So let me just share my screen. Let's see. So if you look at what it basically does is when it's writing, it writes in what are called row sets. Each row set contains a number of columns, and the size of the row set you use is constrained by your memory. So you get a sequence of row sets, each with sets of contiguous columns, because it uses financial data works better in a columnar form like that. So basically, it's like this. I'm going to show you a way that if we wanted to do this, we could improve our performance by loading our data in C++, and then using that in Python. So you've seen what Rainer describing, the mechanism to do this the best way, which is PyBind 11, and that's what I'm using here. So this is what I'm going to do is load a parquet file, which constitutes a parquet table, and so I'll use the normal construct of a class, which I call parquet table. So this consists, I have the constructor for it. In the constructor, I follow the standard for parquet in C++, which is arrow. Parquet is a part of the Apache project, so is arrow. So arrow is the internal table format. Parquet is the serialized format. So what we do is we open the file, get the data in. We then create a reader. It handles the memory. This is standard way to handle parquet data. Then we get it into the arrow table, and we get ourselves a schema as well. Now, once we've done this, we can actually what we do is we use the PyBind 11 process to get us to get this constructor into Python form, and now we can do something. So let me show you. If I when we build, it writes to our build directory and sticks it in the lib directory there. That's just the convention we're using. And so I'll load that. I can then, as Rainer showed, import that library, and we can get ourselves a parquet table from our data file. Now, we now have an object, but it doesn't do anything. So let's make it do something. Right. We're going to add a function to it. The function we're going to add is print stats. Doesn't really do much useful, but it's something to show. So we use the C++ interface to arrow to go to our table, get the number of rows, number of columns, and then we go across them and print out their types. Let's see if that works then. Okay, here we'll do that one. There we go. So in that file, we've got 3 columns: time, size, and price, and their types there. That's fine, but we'd actually like to get at that data so we could potentially do something with it. So let's have a look at that process. So we want to get for a particular column to pull out the data, and as I said, it comes in. This is a column-based system, and we each part of the column is contiguous. So let's get it into a nice vector. So the way to do that is to first ask the table for its number of what they call chunks, which is these row sets for each column. We get the number of them, and then we're going to iterate over them, taking and put them into the vector as we go. Nothing particularly unusual there, and we'll see if that works too. So column 3 actually is the price column. So we'll see if we can get that data. Yep, there we go. Nice. All right. Well, now we've done that, it'd be nice to sort of get an actual chart. So let me try that. Okay. Import the necessary libraries. Get a data frame. And what have we got? We've got. In fact, let me just restart this. I've made a slight mistake there because just a second. Restart. That was the punchline there. Okay. Right. Let me. Okay. Restart. Sorry. This is Murphy's Law. There we go. Got the table. We've got the stats there. And just a sec. Now, if we do that, in fact, we don't get the data. The reason is that our time column is an integer, and so is our size column. So we've got to do a little bit more work. If we go here, we see that, yeah, indeed, we're just giving back a double there. So what I can do is introduce some other information here, and we get our we introduce the other types. Now I'll show you what it's actually doing under the hood here. Okay. In fact, as we go through the chunks, the way that the parquet or the arrow system works is in order to go through all the data in the array, it uses the visitor pattern, and you see it here, except visitor. Now, in order to do that, we have to construct a visitor. So what we do is we derive from the array visitor provided by arrow, and we implement the visitors for each of the types. We've got to pass them a function object, and luckily with C++11 we have lambdas. So our lambda is very simple. It just takes whatever the type is and places it back in the vector. So let's just build that. So it's, as you saw with Reiner's presentation, it's building this lib parquet table shared object. That's now going to be available for us up here. If I restart the kernel, get up here. Okay. Bring in the parquet table again. Stats will be the same. And let's see what we've got this time. We have, right. So we have now a data frame, and given it, when we have a data frame, we can get the time is in milliseconds since 1970. So we've got to fix that up a bit and put it into buckets. And then you'll see, we'll see what we've got in terms of time. Yep, we've got, that starts at sort of UK time, but it's based on, so it starts at 1 AM. And then that's the end time. Okay. Let's see what we've got in terms of a plot. So this is the sizes, and you'll see over time we've got a lot of activity here. And then finally, let's have a look at the price. Okay, on this day, a bit of a down day, but nonetheless, nice output there. So you see the complexity, the necessary complexity when you want to get good performance, which is that you are always going to be accepting compromises like this need for row sets and so on in your data, and dealing with those directly. In C++, you accept that because you want to get very high performance. Whereas in Python, you want to be able to see clearly your data, and you'll accept that Python requires flexibility, and therefore the performance is not as good. When you combine the two, you can have your cake and eat it. So I think that sort of sums it up. All this code is going to be on the GitHub. It's we're just going to push a couple of branches, and it'll be available in a day or two. We'll send an email around when it's all in place, and you should be easily able to build this yourself and take it and use it as a starting point if you want to do interesting stuff with C++ and Python. So thank you.
Did you mention as well the link to the GitHub repo? Or, oh, sorry, you've just gone on mute again.
Yeah, we'll send around the link because we've just got to get a little bit of tidy up, get it into a more sort of comprehensive form.
Yeah, I'll send an email in the next couple of days with links to all the talks and the recording as well. So you should get that soon. Okay, so let me get to the questions now. We've had quite a few interesting questions. And by the way, if you see a question that is maybe low down on the list, do upvote it. So I've kind of sorted these questions by the most upvotes, just the way to kind of prioritize, because we might not get a chance to get through everything. So do upvote any questions that you'd like to see answered. Okay, so let me start with the first question. And again, feel free, either Antony, Richard, or Rainer, to offer your thoughts on these questions. So someone asked, what is your view on using Bazel for build system integration?
Can I jump in here?
Yeah, do it.
Yeah, I mean, I'd start by saying it's probably a really, really good idea. It's not something that I've worked with per se, but clearly it's built by Google, and one thing that Google do very, very well is engineering at scale. You know, I'm not sure if everyone knows Bazel, but one of the things I'd say is for those who don't, is it's described as a hermetic build system. And so by that, it means that it pulls down all of the kind of environmental dependencies and tools that you might need as part of one overall process. What I would say is when I'm using CMake at places, we've also tried to make CMake as much as possible into a hermetic build system by building in a containerized Docker environment with the latest tool chain, latest compilers, latest all the bits of software that you want in your build. Obviously you can build some things you need as part of the build, but you want to make sure all your tools are there and kind of work in that hermetic fashion anyway. I've worked in lots of banks and places where teams get stuck on a version of the compiler that is 10, 15 years old. And that's a really horrible place for somewhere to get. So I think using a tool chain like Bazel, where it considers all of the build requirements as well as everything else, is a very, very good idea.
Okay, that's very interesting. Anything else to add, Rainer or Richard?
No.
Okay, great.
I have to admit, I already answered at least 10, 15 questions. So
yeah, that's fine. Yeah, I thought
okay.
what I can do, I'll click into the answered questions as well, because I think there were some
I did
pretty good questions there as well. I think the main reason was just so people who are watching recording afterwards will also be able to see the questions. Okay, so Sam asked, can metaprogramming be used in the example you used for various exchanges? So I believe, was that your example, Antony?
Yeah, well, I think, let me say well, first of all, I'll start by saying that as somebody who's worked in a whole load of industries, I've worked in video games, I've worked in quant finance, I've worked in just general finance companies, worked in investment banks and hedge funds and trading companies. I think low latency trading specifically is known for having an affinity with metaprogramming. And I think, some of the people here, who know who my most recent employer was, they were very well known in the industry for using very extensive use of template metaprogramming. And I've certainly, absolutely, for the exact use case that you're asking about, absolutely, we were using huge amounts of metaprogramming. We were using just the techniques I was describing, where we were getting exchange, PDFs describing the protocols of the trading exchange. If we got a new version, we pushed it into our build system. Our build system would extract the data, it would generate a load of messages, and then those messages then get used in the trading system. And the trading system itself would be using a huge amount of metadata to analyze, using kind of reflective information about those structures, and try and work out the nature of the exchange. And then, as much as possible, higher level code was then using that metadata from the code and from the reflection and from the kind of templating techniques we were doing, and using things like traits classes and all sorts of metaprogramming stuff that we were doing. We would try to write the high level code in a completely generic fashion, so that you could plug in any exchange and the high level code would analyze the low level code and work out what its characteristics were. Yeah, and that's really useful in trading because of this problem where you can have hundreds of exchanges, each of which has different behavior. Some exchanges support auctions, some do L1 market data, some do 5. If you're a futures exchange, you've got 5 levels of your order book, but they're always fixed. L3 L3 exchanges where you're looking at single orders coming through and you're building up the complete order book. They're far more complicated, and you want to be able to write your code so that it's not specifically customized for any one of these scenarios. It can just work with them, and that's all done through metaprogramming.
Okay, let me just add, PyBind 11, the magic of PyBind 11 is based on template metaprogramming. So template metaprogramming is all over the place. Seems to be.
Yeah, absolutely.
It's essential.
And also,
yeah.
I might just add to that and say that it's one of the things that's getting discussed in the committee a lot, about how to make those kind of facilities more useful going forward in future versions of C++. We've also had Herb Sutter put a really great proposal out about meta classes, which was an approach towards generative code techniques in C++, which right now, because we're Yeah, absolutely. And because we're lacking those features in the language, that's why we have to go to Python. I mean, I'm not saying we won't when we, that Python won't do it better, but actually, if you had those in C++ right now, you could stay on one tool chain and not have to move between multiple languages.
Mm.
Yeah, metaprogramming is, I mean, metaprogramming is essentially a discovery. Mostly it's a discovery that was
I have
made.
to say it's a discovery from it happened in Germany. Erwin Unruh, Siemens employee.
All right.
He discovered it. And I have to say, Unruh, you don't know what this means in English. The opposite of silent. This is a German word, which is extremely nice, I think.
Okay. Well, yeah, and what it's an amazing thing, interesting thing to make for a language to be so complex effectively that you can make discoveries in it, and but what's come out of it is now an essential way to make the most of C++, which is to get the performance. If whatever you can do in compile time, you should do it there, and then I think the language is evolving to make it as easy as possible.
And correctness. If your program is broken, it breaks during compile time.
Yeah.
Yeah. And if we're lucky, we might get refl X, which is a new keyword, which was, people have been trying to get in since C++ 20 at least. Looks like it's going to go into C++ 26, or at least not 23, but at least 26. But that'll be a keyword which will give you access to a whole load of kind of reflection-like capabilities, which will completely extend what we can do in metaprogramming.
The idea of reflection at compile time. I mean, reflection, no, fine, but reflection at compile time, it's lovely. Yeah.
Very great. Thanks a lot. So Josh just asked, just a reminder, the links will be shared at the end. So I'll send an email around later with the link to the GitHub and presentations. Okay, someone asked, is Corba any good for interfacing between Python and C++ code bases?
Corba, that's a word I haven't heard for a long time. Go on.
It's still used in the, I don't know, say it in the military domain. They are seldom used still. But honestly, we also had a big client server architectures in my past. And I evaluated many of these tools, including Corba. And what I don't like about Corba is it's a binary protocol. So from the performance reason, we decided to use SOAP in this implementation in C++, which is called GSOAP, which is pretty fast. It was fast enough for us. So it's an XML-based protocol. It's a text protocol. You can easily debug it, but it's a binary protocol. You have issues when you have an error.
Interesting. Okay, yeah, thanks a lot, Rainer. So another question, how does Rust compare to C++? I guess this is, can answer the question in many ways, but someone added a comment, with regards to speed. I guess there are many to look at this question.
Well, I don't have much experience with Rust, but enough to say that, in my opinion, and it's an area in which opinions can get you in some. Well, some people have strong feelings about these things. I would say that Rust is more a competitor with C. It is beyond C in many ways, but I think that's where it's placed in its at the moment. And C++ does have, well, it's one of its great selling points is its vast amount of functionality, which Rust can't match yet. Now, you did say in regards to speed, if that's the question, I have seen some statistics which suggest it's about on par with C++. You guys got any more information there?
I mean, one thing, I don't know Rust particularly well, other than trying to learn it a little bit at home. One thing I will say is it gets mentioned in C++ committee meetings quite a bit. It's something that people seem to have a huge amount of respect for. They see a lot of interesting ideas from kind of language evolution point of view coming out. And I think clearly it doesn't have a lot of the historical baggage that C++ does. C++ has 40 years of code that it has to be backwards compatible with and not break ABI, and that's just huge. That's a huge drag on C++ in terms of its ability to evolve and compete against Rust at this point of time. And Rust, I think, it's going to be very interesting because it's going to be changing much faster. Presumably, the longer it's around, the more that's going to slow down because it will begin to inherit this kind of baggage as well. But yeah, it's very interesting.
Let me just add one thing. The Python we use is based on C, so it's implemented in C. This is the reason why it's so easy to talk between Python and C++. But there are different implementation: Python, Java, Python itself, Python. But there's also seems to be a new implementation in Rust, and I'm really curious what will happen with this implementation. I'm not 100% sure in which state this project is. Maybe Antony, you know something. I don't know anything more, but there seems to be a Python implementation in Rust evolving.
Yeah, and it's probably worth saying as well. I mean, clearly there's certain things that Rust has got right, like the fact that you are warned about memory errors, that you have to do everything is safe by default, and then you have to coerce it to being unsafe, is the opposite paradigm to C++. And clearly that's the net result of probably millions of bugs throughout time. It's often memory safety or running off the end of arrays or things like that. So certainly there's discussions about how can we improve the C++ tool chain to take some of these ideas. Now, what that will look like, I don't know, but clearly people are learning from the experience of Rust, and that's valuable.
I also say that C++ does evolve and has evolved, in fact, very rapidly, even with the difficulties you mentioned, Antony. For instance, I remember, is it like I'm old enough to remember? Well, anyway, when Java was considered to be, it was going to come and no one would use C++, given the existence of Java. And then C# was in the same category, C#. Why would you ever use C++? But in a way, both of those languages, they have massive areas, but I don't think they're really as central to as many industries as C++ is to this day. There's another arguable point, but certainly they are no greater scale compared with C++ today. And my feeling is that, in fact, we're in an expanding universe of languages. So probably Rust will develop and we'll get a great following and great set of usage without necessarily being a one which reduces the use of C++.
Yeah, I mean, I think also what's interesting from this whole thing, I mean, there's not just Rust. It's also worth mentioning that there's things like Zig, there's Val, there's forget the name, the one Google's bringing out. Carbon, yeah, exactly.
Okay, this new guy.
CPP2. I mean, basically, we're in a bit of a golden age for language design and evolution, I would say. And I think it's going to be really interesting to see over the next 5-10 years the ideas that are coming up in these different languages and how they cross-pollinate. Because C++, certainly lots of languages have stolen ideas from C++, but it's now trying to integrate those back in, and that's going to be happening with all of these languages. So who knows where we'll be in 5 or 10 years with this.
Yeah, thanks a lot. That was really interesting. Okay, so Christian asked, is there any efficiency loading parquet files from C++ than in using Python library for doing it? And yeah, and then Josh just added a comment about Deephaven, which I've heard really good things about myself. I haven't actually tried it, but it's just another library on top of that. Sorry, Richard.
Well, what I'd say is that actually in my I thought I wouldn't bother with it, but I could have gone down a little bit further in my notebook, and I've got a couple of examples of importing that file using native Python libraries, which and it's not much point because if we would go into the implementation of those libraries, look at the source code, you will find a whole lot of, most likely we'll find a whole lot of C++, and there's one implementation, PyArrow, which is clearly on Arrow, and we'll use the Arrow C++ library. So like every major usage, they do something like what I did and cover the whole functionality of the whatever they're on top of and provide that in Python via C++. What I would say is that in something like a trading environment, you may want to do something a bit different. You may want to, all sorts of things you might want to do, and having the flexibility to do that and create improved performance where you need to is just this wonderful value of the integration of Python and C++.
Yeah, I guess with, you know, it was a kind of a starting point into backtesting as well, that example you gave.
That's right, yeah.
I mean, one of the reasons Python's so slow is because it does type checking on for loops. And, you know, whenever you kind of got the load data, then you can start to begin to write your strategy or whatever in C++. So I guess, you know, Richard and Antony, would you be welcome contributors as well to that GitHub project?
Oh, absolutely.
Yeah,
We're going to get it in great state so that it will hopefully build everywhere and have its coverage and so on, and then we'll you know, think of it as an experimental area, I think.
Yeah, okay, great. Yeah, so please do, any ideas you have, you can open an issue or contribute on GitHub.
Yeah, and just worth adding to that, I mean, I think our motivation with creating little examples like this is the fact that, you know, there's often, you know, I speak to a lot of people who are learning or wanting to learn C++ or wanting to learn Python, and it's not always easy to know what's a good source of information. There's lots of examples on the internet, for example, you know, something like CMake that we're using. It's very hard to learn because there's so many bad examples of how to use it, or examples that are based on, you know, how to use it 5 or 10 years ago. And so we're hoping with these samples just to create small little examples that people can follow and copy and modify and add bits to, just as a way of learning these techniques and you know, starting from a good base.
Okay, great. So someone asked, how can one transition to a finance or, I guess, algo trading career coming from another industry within C++?
Well, I'll say that in my last role, I was doing a lot of recruitment. I think it depends whether you're talking about an investment bank or a trading house or, you know, or a hedge fund. You know, if you're working in a quant group, they tend to want people who have, you know, mass PhDs or masters. But at the same time, there's normally a shortage of people with technical skills in those backgrounds. In high frequency trading, you know, I used to work in video games. You know, I think there's an acknowledgement that there's not enough people in the industry with those skills, and so most places will consider people from other industries as long as they can show that they're technically strong in those skills or some skills. And of course, you know, if you're turning up to interviews and the stuff you don't know, I mean, the main thing to always be clear on is, sure, I don't know that, but I can learn, because that's what you want more than anything, is people who are able to be self-motivated about going away, finding some area, researching it, learning the skills and developing their skills, because nobody knows it all.
I'd say, you know, you can prove yourself, create a GitHub now if you haven't got one already, and get coding. Do something tricky, complete it, put it out there. You know, get a few forks, get a few stars on it. That's real. So you can show that to your prospective employers, and they'll take it seriously.
Yeah, absolutely. I mean, if there's a GitHub link on someone's CV, I'll always have a look at that. And the other thing to add is I've wrote an article that I'll post about this topic before, you know, where I talk about getting involved in things like open source projects as a way to learn and trying to find mentors who are more experienced, because I think that's a big part of the learning process.
I wonder, I mean, this might not exist, but do you know if there's like a Euler project, lead code, or, you know, advent of code equivalent for finance industry programming? You know, like finance problems as a way to kind of get familiar with the type of things you might be doing. Does anything like that exist? Or if anyone's got,
I know of. I mean, one thing I would say is I think things like advent of code, I mean, I think they're great for practicing certain aspects of programming skills, but I think they also, you know, the advent of things like HackerRank and kind of competitive coding to some extent is a little bit unhelpful. One of the things we saw earlier this year is we saw a huge number of candidates come in who were from a part of the world that was very heavily into competitive coding, and we got a lot of guys come in who were excellent at these competitive coding tests, but actually were lacking a lot of the fundamental skills. And so, that's only sandbox that is probably captures about 5% of what you should be good at as a programmer. There's lots of things like build systems that a lot of people don't enjoy learning about that, but actually, if you're going to be a good software engineer, that's core infrastructure that's pivotal to the base of everything that you're building on. So if you can't do that well, then everything else in your project is not going to work well. And so there's a lot of emphasis not put on some of these skills, which don't, they're not as sexy in terms of things that you might learn, but actually they're really, really important in terms of fundamental software engineering.
Yeah, that's really interesting. Okay, let me move on to the next question. So Sam asked, Rust plugs in well to C++ as well as Python. And he asked, will we see Rust replace or Rust be used as an alternative glue between both languages?
I assume when you assume that Python could be implemented in Rust, this would be also a way to go. Why not? But I'm not sure if the Rust implementation, the Python implementation the Python implementation in Rust will be in lockstep with the C implementation of Python. If not, there is an issue. But this was in the past always the issue. The Java implementation was behind, the C# implementation was behind, and so on and so on.
I would have thought it might add a layer of complexity, to be honest.
Yeah. Okay. Interesting. So Shoshvan asked, hope I pronounced your name correctly, how's the usage of Q and KDB in, I guess, the finance industry?
Depends on the company. I know some funds that use it in London. Certainly, it's been used in some investment banks that I know. But I think it depends very much on, companies' technology stacks. I think there's a lot more alternatives to KDB than there used to be, and I think Python has probably eaten some of the space that things like, the Q language to access KDB used to take.
It's a great system. I've seen it in a lot of places, but it's sort of tapered off. And I think, as you say, there are people who have come to, things like pandas is there, and columnar storage is become understood to be the way you should deal with time series data, and then so some things have come out of it, and Q is, I don't know, some people do really like it, but I would say it's one of the most write-only languages that exists. I think Jahan, you like it, and I do know some other people who like it, but it's a tough one for me. And I come from C++. I'm saying it's tough. I don't know what do you think, Anthony? It's a nightmare.
It's very niche. One of the things I'll say is I think if you look at job adverts that contain KDB, you're slowly seeing the salaries for those jobs going up, which suggests to me that it's becoming more of a niche skill. Not as many people are learning, and it's going kind of into the COBOL space where now there's companies with these systems that has been wrote in this write once language, and now they're having to pay huge salaries to people who actually have those skills to come in and work on those legacy systems.
Yeah. So it pays to be a Q god, right?
Yeah, no, I used to use it quite a lot actually when I was in an algo trading role, and it's a very expressive and great language for running all kinds of queries, and it provides a lot of functionality that you would actually need dealing with time series data. So the things like as-of joins, when you're dealing with time series data and you want to get what was the last trade as of this timestamp. So when you did a table join, it would kind of automatically look that up. What I've found myself slowly doing is moving more towards Pandas, but Pandas is actually built in, Pandas and Python actually is built in quite a lot of that functionality. So it's one of those things that if you haven't done it in a while, or I haven't actually looked at Q or KDB in a while, it's quite easy to forget. It's not very easy to follow language, but you can get a lot done in such a short amount of code as well. It's a very powerful language and store of data. Okay, so Christian asked, so the Excel interface for trading, would that add complexity on time for sending orders? Yes.
The Excel interface for trading, right? So I guess my first question would be, is that Excel interface interfacing with C++, or is it interfacing with Python? Now, if it's going through something like PyXL, you run a PyXL server on your machine, and you connect to it in your Excel session, and then remote communication, with a separate process somewhere, usually on another machine, but possibly on your machine. And so obviously that adds overhead because it's got remote process communication. Same time, I think writing bindings to Excel isn't particularly easy. There's a Microsoft API for Excel in C++, and from having looked at it, it's very C-like. There's a couple of open source projects which aim to address that and generate bindings for C++ to Python and Excel. I think there's one called Excel Oil that looked pretty interesting. But I think most people probably don't want to spend their time writing bindings to Excel to C++. And so if you've got a Python binding and there's a Python library that does it, unless you really care about performance, probably you just want the ease of development.
Yeah. I guess Excel's been around for so long, and it's it's such a easy to use UI for displaying and manipulating data. So it's hard to think that it'll ever disappear, even though many of the things that that were commonly done on Excel are slowly moving to Python and other languages. I think it's here to stay. So things like this will always exist, and people will always find ways to do complex things in Excel. Yeah.
I mean, I agree with you, but I think the one problem that I saw at investment banks, and one of the banks I was at, there was a real push to get rid of all spreadsheets, was because you can get an error in a spreadsheet and it's very hard to know where the error is. And so at least if you have an intermediate layer of Python, you can have a whole load of unit tests, either your build system or somewhere on CI, so that you can write your spreadsheet, but then you can run your tests and see that the logic is at least working. So even though that adds a bit of an extra layer of abstraction to go through and thus some cost, that cost is probably worth it for anyone, anywhere where you care about not losing money or making mistakes.
Yeah, I totally agree. I mean, it's the way it should go, but I guess in practice it's not always the case.
No, very true.
Yeah. So Srinivasa asked, would the scare of the economy downturn in the coming days? I'm not sure is there going to be a downturn in the next coming days?
Something we don't? Can we look? I have to make some trades, guys. Just give me 5 minutes.
Let's trade. Yeah.
Something. Is it wise to switch to the finance domain, such as algorithmic trading, in these turbulent times? So I mean, are these jobs recession proof, or?
Well, are any jobs recession proof? Didn't everyone think that big tech was recession proof? And now we've seen Facebook and Google and a whole load of these tech companies laying people off recently. I think if you want to be recession proof, make sure you're at the top of your game and you're always working to develop your skills, and then you'll always be able to find work.
Let me just add it. Of course, I know it from C++. There's a big demand for good C++ developer. You cannot imagine it. In meaning, when you are good, you are recession proof. So in the German industry, this is unbelievable, and Europe, unbelievable.
And not much less for Python programmers either.
And this right? Python also, but this will even become more dominant in the future, because you see, cars are now not anymore based on mechanic; they are based on software. So this field will increase and increase, and CAS is system-related programming. Therefore, you need C++ nowadays.
Yeah.
I sort of expected to see other languages come more into play in prominent companies rather than C++.
There's one issue.
Yep.
You have to be certified, and there are only a few languages you can use in this domain. Rust is maybe too volatile, too new. C has too less abstraction. Ada, only a few people know this programming language. So what is left? Nothing.
Yeah.
At this point in time.
Yeah, that's right. Yeah, I mean, I sort of had expected a movement like that, but in fact, what I see, it's anecdotal, is I see C++ everywhere. Really, astronautics, as you say, cars.
Don't forget about my favorite project, e-bikes.
What's that?
E-bikes.
E-bikes, C++.
E-bikes.
Yeah.
Bosch has now a big new part in their companies only building e-bikes.
Right.
They become the new cars, essentially.
And there's C++ as well?
Exactly.
Really?
I give at least 5 classes a year for e-bikes, Bosch.
Right.
Yeah.
Right.
That's good. I mean, I heard that Elon Musk won't build e-bikes at Tesla because he had personally a bad experience with I think he had a motorcycle accident or something when he was younger. So
he's traumatized by them.
Yeah.
Well,
Musk
companies, SpaceX, everything's C++. Tesla, C++. Yeah.
I mean, is there really a demand for Python? I mean, you could see I can imagine the supply-demand curve for Python developers looking very different from C++ because, the barrier to entry into learning Python is much lower. So
honestly, you should know more than one programming language. You should know at least a compiled one and an interpreted one. And therefore C++ and Python is a good choice from my perspective.
Yeah, it's certainly, I mean, I think it's always worth remembering a programming language is just a toolkit. And so people like to get emotionally attached to these toolkits. We've seen, flame wars over which language is the best. But at the end of the day, it's about which language solves the problem that you're working on.
Yeah.
So Jeff Keane asked, what's the uptake of machine learning usage in the industry? So I guess the finance industry.
It's coming. Certainly at places I've worked, I've had machine learning teams. I think they've been quite small teams, and certainly some of the places I've worked, code that they were working on was kept isolated from the rest of the company. And so there was clearly seen as being monetary value above and beyond in that code compared to other code. So I thought that's interesting. It falls in the kind of domain of, certain teams you work with will be building trading logic, and that code will be kept secret from everyone else. So it falls in that area, and I think it's going to grow pretty significantly. And if you see some of the things we've seen in the last few weeks, like Stable Diffusion, the generative AI or ChatGPT, I mean, I think we're beginning to see some really interesting breakthroughs in AI lately.
Yeah, I think so. I mean, I'm not an AI expert, but I sort of tend to think that we're going to get some interesting results from very short-term machine learning in the order book, which will necessitate a fast language, which I think it will be C++, to do that. I think that's must be happening, and it will
also be.
Yeah.
I mean, I think it'll be interesting to see where the law of unintended consequences plays out here, because inevitably some people are going to use AI to trade, and some companies are going to be trying to pick off those companies whose AI algorithms are, are honing in on optimizing on one specific space, but leaving a big, huge black swan that they haven't seen. And that's probably, we're going to see some interesting stories crop up, I think, over the next decade, where those kind of events happen.
Yeah, definitely. Yep. I think, with there's also a lot of use of statistics in general, or statistical learning. So I mean that there's a very close tie between statistics and actual machine learning. So from my experience, statistics actually at the moment is the most dominant force in terms of, well, certainly algorithmic trading when you're dealing with time series and time series forecasting and trying to calibrate models. But I can certainly see things like recurrent neural networks used for time series forecasting becoming possibly more widely used. It's definitely a very interesting area, and with things like PyTorch and all kinds of libraries out there at the moment, I think the use of this would just grow. I mean, it's just a very, very interesting area.
We recently talked to two AI machine learning experts on a webinar, which we can sort of send around the link to that as well. Which was to me, it was just like a taste. There were two totally different areas. There was a neural network solution, and then causal AI, which is a whole different area of AI. When you talk about AI, there are many areas. I 30 or 40 different areas, and each of them may well be applicable to trading at different timescales. And we're going to see a lot of this. This is going to be only increasing.
Yeah. Okay. Yeah. No. That's thanks for reminding, Richard. That's
we should put that in the.
Yeah. Maybe we'll share that in the Telegram group or something. Actually, let me throw a curveball question, which I think someone else may have alluded to before. It's not actually on the questions here, but have any of you what's your opinion of ChatGPT?
Yeah. Someone did ask that question.
In terms of like people writing code using this, or is there any way of leveraging this technology within kind of a software development environment?
So actually, somebody has just put a comment into the algorithmic trading group about this and said something along the lines of, it literally wrote the whole algorithm for them, which is interesting.
Oh yeah, sorry, I haven't been following that. Yeah, no, it's pretty interesting stuff. It's so what have you guys had a chance to play with it yourself?
I've played with it. And I mean, I want to play more really, because but it almost it not quite frightens me, but I'm trying to think of a way to make it. Can you get a GPT sort of in a loop that sort of a meta type of process to solve some I mean it's phenomenal, isn't it? Right? It's remarkable.
Yeah, I think the other aspect of this is the whole thing like Ghostwriter, the AI assisted code writing, which I think we're also going to see that becoming a much bigger kind of learning tool. If people can have, direct the AI and have it write things for them, that's going to potentially change the dynamics around how hard it is to hire people, or how hard it is to train people and get them up to speed. I mean, it's hard to know what that effect on the industry is going to be as well.
Yeah, I think there was talk from one of the OpenAI developers that they might have some kind of hash or checksum on the actual responses. So we'll be a way of kind of verifying whether it's been used for plagiarism or something. I think that's a good idea, because it stops. Obviously, you don't want kids and people using it for their homework. It's not really gonna.
It would be so. It'd be so difficult. Can you imagine a teacher? They get often the classes are too big. They don't have enough time. They're not even paid for their marking time, and they've got their own families to deal with, and they've got a stack of 30 different essays, and they just that's a particularly good one. Oh, not bad. Obviously improving, and that'll be the one done with GPT.
Well, clearly the teachers need to start using AI to mark the homework.
That's it.
Yeah, that's a good way to. Yeah,
that's right. Mark this. Can you try? I wonder if we could do this. Mark this according to the certain curriculum. You know, I mean, all this is available on, you know, I'll have to try that now.
Yeah. Okay, let me get to this question as well. So Josh asked, does anyone have any professional opinions on cost-efficient sources of market data for a startup algo trading firm? I guess it maybe depends on the asset class as well. What do you think?
Sure. I mean, we have some knowledge in the crypto space, where, you know, things are more available. What do you know, Antony, about say equities, or, you know?
I mean, I was going to say start on crypto, but I guess you've always got things like TradeView, which is always a way to get going. And I think if you want really, you know, L3 market data, then you have to go to Reuters or Bloomberg or, you know, one of the big providers, or you've got to be co-located yourself. So your options are limited, but you can probably get best bid offer for free on, you know, TradeView for a lot of markets.
Yeah, I mean, you're talking about live market data. I mean, I think everyone makes you pay outside the crypto industry, don't they?
Yeah, I guess live trade data is usually easier to come by, but when you're looking at historical data, especially when you get to level 2, level 3, it could get quite costly, especially if you want a lot of history to backtest. But typically, I think crypto is quite good. For instance, BitMEX offer top of book quote data, so top of book data for free. So you can get that from their website, so they kind of store that down. But not all the, you know, you'll be hard pressed to see someone like CME offer that for free. They'll probably charge an arm and a leg for that kind of thing.
Wouldn't blame them. Who'd blame them? You need it. It's a commodity. Yeah, expensive commodity.
So Kintu asked, can you provide us with any live trade example using your code? I guess we could maybe do another webinar on that. We didn't quite.
We have in the past, actually, and the answer is yes, we can. I wonder if we can.
It's worth putting around the example from the previous webinar we did, where we traded a live algorithm.
Sure. Yeah, that's right. It's
that's still useful.
Yeah, I think so. And necessarily, all these things we do are a little bit contrived because we've got short period of time. But you know, that was to demonstrate ranges. You know, but you can start with that. You know, it's something to start with, and but so long as you understand the caveat that it was an example for a particular purpose. But certainly, you can start that, and you can run it, and it will trade live. So. We can maybe put that in the email that goes around as well. Yeah.
Okay, great. It's gone up to 2 hours, but I'm kind of like, I was watching one of Lex Friedman's webinars or talks the other day, and I noticed like his talks sometimes go on for like 3 hours or 4 hours.
7 hours.
Sorry?
There's one with 7 hours.
Oh, really? Wow.
One podcast with 7 hours is unbelievable. 1 or 2 months ago.
And was there any break in between? Did he like?
No, I don't know. For me, it was too long.
Yeah.
I go by bike, but I cannot go 7 hours by bike.
Yeah, no, we still have a decent number of participants still on, so I guess we can carry on. Unless, you know, feel free to, Antony, Richard, or Rainer, if you want to stop, we can stop early.
What is the ABIDAS framework?
That's what I was going to ask. So Gleb asked, have you ever tried to interpret the BD's framework?
Interoperate, right?
Interoperate the BD's framework with C++.
Who knows ABIDAS? Anyone here know ABIDAS?
Oh, yes. Yeah, I do. So that's a new library. If it's the one I think, it's a new library that's just been proposed for Boost, which... oh, no, it's not. Sorry, it's just very similarly named to a library I was aware of. Okay, so I don't know what this is.
Well, I'm going to Google it.
Yeah, someone Google it, and we can...
I guess we can continue the question.
Yeah.
On Telegram.
Well. Yeah, I think it's better to
perhaps that's
go for Telegram.
Yeah. Okay, so someone asked, so what kind of resume format should a quant dev use?
A resume format.
Is there? I mean, should it be a 1-pager, 2-pager? Does it matter?
I think 2 pages is fine. There was a time in my career where I let my CV get a bit out of control to like 5 or 6 pages. I don't think that's good. Having now spent a lot of time looking at other people's CVs, 2 pages is great. If it's good content. 1 page, people say it should be 1 page. I think there's not, for a software developer, that often doesn't give enough information. Like at the end of the day, what we do is complicated. So, but other people might have a different opinion.
And what are like common mistakes? Antony, you probably, and probably all of you guys have seen a lot of CVs before. What are common mistakes you think you notice on CVs? Like what are quick, easy wins for some people that quite commonly just get overlooked?
I mean, certainly if you have a GitHub, put a GitHub on, make it easily digestible information, because if you've got a pile of 50 CVs on your desk, if one looks like a book or has too much information, that's just a struggle as a hiring manager. You're just gonna, you're gonna veer towards the ones which aren't that much information.
I would say if you've done something that's somewhat different, different and interesting, even if it's not in the area that of your CV. In my I've seen a lot of CVs. I remember some of those CVs, from it caught my attention, and I was interested. I was thinking, okay, this person is no longer just another name, and I'm interested in that they are different, and I think it's good to be different. Good to have some sort of distinguishing aspect. It's good to have in a team. Someone who's an athlete, or has done an interesting, master's or a PhD project on something which is unusual. There's one example is which I think was from Imperial College. A few people worked on the same project, which was modeling the shot of a clay pigeon shoot of a clay pigeon shotgun hitting a thing. That was the project, and maybe it's a cheap way to do it, but actually it does get attention. If you've done something like, if you've got something, do something like that and then present it, I would say.
Yeah. And sorry, go on.
So I was just going to say, I mean, the other thing also is, when you're talking about what you've done, try to talk in terms of the impact it's had on the project you're working on. Don't talk, I wrote this library in C++, talk about how it affected users, how it impacted everyone else in the business, because that's what people want to know, is you're going to come in and be able to have an impact where you're working.
Yeah. Sorry, Rainer, I was going to ask as well, do you cover this kind of thing on your coaching or mentoring, to do with CV writing or?
No, CV writing, not. This is programming language agnostic. My idea is, of course, to make C++ program in particular better, and this is the reason. I'm not sure if I should. I wasn't sure if I should say it, that I want to build a C++ community which aims for one goal: becoming a better programmer. Because learning is not a thing you do in 3 days. Learning is a life, a thing you should do your entire life. It should just be part of your daily work stuff you do. Maybe 3 hours, maybe 2 hours, I don't know it, but it should be part of the things to do daily. And this is something which is my vision. Companies should learn that. Companies should learn that the employees have time to improve their skills. And this is what I aim for. This is why I do this mentoring thing.
Yeah,
I want to have a switch in the mindsets of the companies.
Maybe it's a slightly related question, but Rainer, you get really good invites to kind of CPPCon. You're very successful in the speaking arena, and you're very well known within the industry. If it's someone new, maybe a very talented C++ or Python developer, how do they break into this kind of getting more invitations for talks and so on? Because I think these kind of things are important for personal branding, and the kind of things that would probably look good on a CV as well?
First, try it out. First, maybe just give a lightning talk, which is a talk around 5 or 10 minutes. Then you get your food inside. And second, let me just say something about one of my friends, Jens Weller, who is host of the second biggest C++ conference, Meeting C++. He has a track only dedicated for newbies. Meaning, I cannot give a talk in his track because I'm not a newbie anymore. I was it 15 years before. So the point is, they are looking for new guys, new girls talking, saying something interesting. And I say, when you are really, really 5 or 10 years in your industry, you have a lot to talk about, which is really, really interesting. I always say in my classes, try it out. I even can help you how to make a talk, how to make a sexy proposal. This is the key point. So therefore you would be accepted.
Yeah, that's really interesting. Okay,
So I might just add to that one thing that actually giving talks is one of the best ways to improve your skills. Because if you're going to go up and talk about something, you have to learn about it. You know, it's active learning, not passive learning. People should always do talks and put themselves forward, even if they don't think they're experienced enough, because it's a great way to get known and to meet people and to develop your skills.
Let me just kick in. When you give a talk, you immediately know the very interesting people. You see the very interesting people, you talk to them. This is because there's often a speaker's dinner. Therefore, you sit on a table with Bjarne or with Antony or who else, which makes it really, really interesting. You know the people you so far only have read about because you read their book or something like that. This is really, really interesting. I now know all of the people you know from the C++ community personally, or almost all of them. This is extremely interesting, extremely thrilling. This is just pure energy, honestly.
Absolutely.
Yeah, I'll definitely agree with speaking to learn, and something I used to do a lot with as a PhD student. We used to give like kind of each other graduate. One of us will pick a topic and learn about it. So I guess that's something maybe we can encourage within the group as well. Maybe groups of people can get together, someone learn, a particular aspect of, programming, Python, C++, or even trading, and, just present it to each other. I think this is the kind of thing that will definitely help in building that confidence in talking about a technical subject and really understanding it well.
We had an idea of what was it? What we do? Sort of like every couple of weeks, have a time where we will always be present and basically a Zoom meeting, and those people in the community, anyone who wishes, can join, and we'll discuss. Maybe we'll each time have a topic. I think we should possibly do that maybe in the new year, starting in the new year.
Yeah, definitely.
Honestly, this was the starting point for my career as a trader. I 2 times created such a movement in a company. We called it we called the first one design pattern round, because we talked about design pattern around 24, because this was the time when the design pattern were really on vogue. And this was the starting point for me. I created such a movement, and what happened to me? I became a trainer, I became a mentor, because this is just what I do. This is just what I love. I want to help people to become better.
Yeah, and I think it's worth adding, if people want to get into this and want to have experience giving a talk, and it is nerve-wracking, most conferences nowadays do what's called lightning talks, which is where you come on and you do a 5-minute talk. And so it's a very low barrier to entry. Everyone's going to know that a lot of people doing it for the first time, or just want to get some experience. And I think the whole kind of idea around it is very supportive of just dipping your toes in, getting a bit of experience, and then getting some feedback and building your confidence towards going and doing a full maybe half hour or, building up to a bigger talk, but it's the whole idea of us encouraging it.
Definitely.
When someone of the listeners is still interested in this stuff, please contact me. Sorry, I have to say it, because I have a lot of experience. I gave at least 100 talks in the last 10 years, maybe more.
Yeah, you can contact
public talks. I don't talk about the other ones.
Yeah, you can contact Anthony, Rainer, and Richard on the Telegram group as well. So
I can only say it about me. So
okay, so let me get on to, we've still got a lot of questions. So Camille asked, how useful are assembly skills to have in the finance industry? Is it just to the extent of understanding the output of the compiler during optimization stage of software development? Or is there any routine handcrafting and anyone that is dominant CPU?
So yeah, I mean, I've not seen a handcrafted assembly for at least 10 years. And I think if somebody was doing it now, they would have to give me a really, really good reason. But yeah, when I was in the games industry, certainly we used to have handcraft assembly. Nowadays, you've got intrinsics, and if you write it in intrinsics, the compiler is probably going to generate better assembly than you anyway. So if if you think that's not the case, you're going to have to come and to get it for a code review, you're going to have to provide some pretty hard evidence of what you're doing is better than what the compiler is going to generate for you. That said, understanding assembly is what's important. It's not just understanding assembly, it's understanding how the hardware works. That kind of knowledge is vital.
I think if you've got good assembly skills, you should put that on your CV so that whoever reads your CV will see it. And then you should be very much prepared to talk about it and argue be ready to get into the technical banter. And if I was interviewing, I'd want to talk about it. Tell me more. In what circumstances will your assembly code be better than generated code, and this type of thing?
Absolutely. And also, I mean, with things like Godbolt makes it so easy to learn assembly because it's got a description of what every single instruction is. I mean, when I learned assembly back in 2004, 2005, I ordered physical copies of the Intel instruction manual. Back then you could get physical copies, and I've still got a couple of 1,000-page manuals. They're still on my bookshelf, which are not that different from the versions they're putting out today, but that was how I had to learn, was going through the instruction processor manuals, reading probably the driest reading that you're ever going to do. Whereas nowadays, with Godbolt, it breaks down, it color codes which instructions correlate to which line. It tells you what instructions do. I mean, it's you don't understand how much easier that is as a way to learn. So highly encourage people to be doing that with code, copying and pasting into Godbolt and trying to get an understanding of where their performance is being used.
But I'm always astonished when I give a class. I always ask the people, do you know the 3 magical tools? CP reference is not magic, but this is one of the 3. Compile Explorer is the second one, and CP Insight is the third one. And you may not believe it, but at least only 50% of the people now, professional C++ programmer, know Compile Explorer, meaning Godbolt. This is for me unbelievable, because
absolutely.
For me, I would not regard you a professional C++ developer if you don't know Compile Explorer.
Yeah. Well, also, anytime, I mean, often in my work, I run into compiler bugs, particularly when you're using the latest compiler. And when you get a compiler bug, nowadays, having Godbolt and being able to paste a segment of code, cut it down to the smallest reproduction case, and then instantly test it across 3 or 4 different compilers, and work out what's the breakage and how's the compiler misinterpreting the code. It's so easy nowadays.
I did it in my past with object dump. This was terrible.
Yeah, you can do it that way for sure, but it's painful, isn't it?
It's not fun.
I saw a really cool video on YouTube recently. I'll just post it on Telegram as well. It was a guy basically programmed Fibonacci on a breadboard, basically walked through the entire assembly code and basically showed how it would work. So I thought that was quite interesting. Maybe
Generally speaking, there are plenty of us. There's plenty of there's a lot of value in being a very good assembly language programmer. I mean, you have to remember that people are out there writing assembly language now. It's not as if it's someone must be. They have to be, or else how does anything, how does anything?
Let me quote Matt. Less assembly is better. This is all what you should know when you use this tool. This is from Matt Gottbold.
Oh yeah.
Do you think with the advent of more custom chips on the way, there's more competition with Intel, with AMC and everyone, and is there going to be more need for this kind of thing? Writing assembly language to kind of.
Well, there's risk. What do you call it? Risk V. There's more things coming.
Absolutely.
And,
look at the new MacBooks coming out. They're all coming out with M2 chips.
Yeah.
I mean, if you look at the Intel instruction set, it's a beast. We've had to have rex and then vex prefixes to extend the instruction set so that you can have instructions that are now I forget how many bytes long it is now, but they've grown in to make the instruction set backwards compatible and have what is it at least 10 different variants now. It's very, very expensive. Any new chip designer coming in and designing an instruction set from scratch that doesn't have to support backwards compatible code, their instruction set is going to be far more compact. That has to be more efficient on your data, and your data cache, your instruction cache, and actually, when you get down to really profiling code and looking for bottlenecks, you'll remove data cache misses, but once you've got rid of those, it's instruction cache misses that are the real killer of performance. Because if you get an instruction cache miss, with a data cache miss, you've got out of order execution. Your CPU goes off and it finds some other instruction to execute, and that's non-dependent, and it just executes on those. With an instruction cache miss, your CPU stalls and it can do nothing until that data's there, and then that's going to be hundreds of clock cycles.
I mean, is there an argument to design a chip that's especially good for running C++ or Python? One that's specially designed for, I guess, compiling or getting down to the machine assembly code in the most efficient way, or running the code in the most efficient way, or even going the reverse, designing a variant of those languages that will fit well with the chip design. Is that even a reasonable?
I think it's a question for an electrical engineer, which I'm interested in hardware design in terms of making it run fast, but how to get the best out of it, I don't. I know from talking to the guys who were doing FPGA where I used to work, it's a whole different ball game, very different skill set.
Yeah, very interesting.
Perhaps worth adding that, as well as FPGAs, that our companies, jump trading is probably the one people know, that are investing a lot of money in things like ASICs and having custom hardware, at a huge expense burnt in. So it's clearly there's money to be made doing that in the industry.
Is it worth learning electrical engineering or just to basic level?
Yeah, I think yeah, and I think certainly I know from talking to people around recruitment that finding FPGA engineers is very hard, probably harder than C++. Because it's a very niche skill, and there's only a few places they can recruit people from.
Let me move on to the next question. Yeah, lots of interest. We could even have a webinar on some of these questions. We could go on for a long time. So Mukhadin asked, should we even make programming languages? Are there tools to make programming languages? Is that even worth?
Well, I think this touches on the whole, the kind of ghostwriter thing. And so ghostwriter, I think, is the GitHub AI generated, code generation tool, of which there's a couple of other ones. I've not had a serious chance to play with them, but I think it is a glimpse into the future that, should we even be writing programming languages? Probably, but probably should we be writing code? You know, I think more and more you're going to want AI, maybe not writing the code for you, but maybe checking, maybe AI code review systems, or picking up the kind of errors that humans are very bad at picking up, but you know, we make all the time.
Yeah, there's some sort of contradiction in terms of when it comes to having code being written by an AI, I think, but in my opinion, because to me, writing code is really, as much as anything, a mapping from the human brain into, you know, it's a mapping of human thought. You have to be able to express your thought. If you can end up with software systems which help you express that thought, then that's what a programming language does. If you've got a more high level one that you might call an AI, then in the end, it's sort of the same thing, you know. And I think there is going to be a progression in that direction, and programming in 30 years is going to look a lot different, isn't it? You know.
Well, absolutely, and you know, just to add a point to that, I mean, I think it's worth perhaps touching on the Unreal Engine, which, you know, when I worked in video games, everyone used to write their own game engine. Nowadays, it's dominated by Unreal Engine, and the other one slips my mind. Anyway, Unreal Engine has its own scripting language in, and a big reason for the introduction of the scripting language was that majority of the bugs that they were finding in their code were running over the end of an array, and so they designed their language which solved, you know, going out of bounds on their array, which obviously we've now added all sorts of new functionality to C++, things like span and you know, using iterators and ranges and things which you can check. But 10, 15 years ago, that was a huge problem.
Yeah.
Particularly in the games industry, where, you know, people didn't used to like to use the STL because it was seen as having poor performance, which nowadays you can't imagine anyone writing their own, you know, writing code base without the STL.
Yeah, let me, I'll move on to some other questions, because I think there's some people who didn't really get a chance to ask. So I think this is an interesting one. So Ravi asked to Anthony, with the C++ standards coming at nearly 3 years, what's your guide to adopting particular one? Because with me, C++, I guess he's on C++ 11. Should I move to C++ 14 or 17?
So what I would say is, I always like using the latest version of everything. And you know, my last job, we put a lot of effort into solving the problem that I described, where you end up stuck on a code base and you can't upgrade from C++ 11 to C++ 20. I think if you're in a situation where you're upgrading, you know, GCC from GCC 9 to GCC 10, that's very different to upgrading from a compiler that works on C++ 11 to C++ 20, because you're doing the upgrade in small incremental steps. And I think that's a much easier change to do than take, you know, a million line code base and try and change it so that you upgrade 3 different versions of C++ in one go. So I think, you know, it depends to some extent on your environment. If you can't easily install compilers on your machine, like a lot of companies, that makes it difficult. That kind of is one of the main reasons why I think using a Dockerized, you know, containerized build system where you've got all your build tools in is very, very useful. But also, once you've got that system in place, you can push out updates to the whole company of a compiler. And, you know, when people log on in the morning, they'll get a little update saying there's a new version of the compiler. Do you want to update? Yes. And so, you know, within the space of a week, you make sure the whole company is on a new, you know, the latest version of the compiler. And that makes it very easy to upgrade code bases. Where you don't have that control, it's very, very difficult, because there's always somebody who hates upgrading, who just won't upgrade no matter what you do. And so they'll sit there, they won't upgrade their compiler, and then, you know, people start checking in changes that work on the latest compiler, and then they'll start shooting out emails saying, hang on, the build's not working, what's going on here? And it's, of course, it's that, you know, the world has moved on, but they haven't.
This is, by the way, pretty often in the embedded environments. They have often very hardware related dependencies. Sometimes they cannot even use C++ 11 because there's no C++ compiler available for this specific hardware. So I sometimes give classes for companies which cannot even use C++11 nowadays.
Wow. Yeah, I mean, that's really,
But let me add one point. You should not go to C++11. At least jump to C++14. This is what you should do at least. And then you can go to a 20 or some way newer version, but not 11. At least do 20 because 14, because 14 at least gives you generalized lambdas, generalized context, and a few nice additional things. Or the use of auto is way more comfortable in 14 than in 11. So this is the only tip I give here. Don't go for 11. Go at least for 14.
I could say that the when C++11 came out, Björn, how do you pronounce the name? Probably Björn said it's like it's a new language.
It feels like a new language.
That's right. And I would say that each version feels like a new language. And when you program with it, the new features are not little fringe things like ranges and concepts. These are going to be central to your programming, in fact, so that once you're programming with C++20, your code is going to look different and is going to be you're going to be thinking differently when you're writing it, and so these are improvements. So I would say that so long as that your compilers are working well and producing good code, you should really be going towards the newest version. I mean,
but
if you're
when your product is certified, you don't want to change it for 10 years, because if not, you would go to a new certification process, which may include clinical and evaluation, and this is so expensive, unbelievably expensive. I was responsible for defibrillator. This is a different domain.
Sure.
And here you have really hard fights.
And it's worth saying, it always depends on what's the internal structure of your company. I mean, you work in a big bank, there's probably thousands of developers, each of which maintain their own build system. If you're in a build system where you build everything from source, that's a really great place to be. And that's where Google are with Bazel. They've got thousands of projects, but millions of lines of code. I think I read, I'm not even going to guess at the figure, but it's definitely probably in the realm of hundreds of millions, and they just build everything from source, and so that's a great place to be. But if you're building a library and shipping it out as a pre-built set of dependencies, and then somebody else is using a different version of Visual Studio with a different runtime, or they're using GCC pre-5 where we had the ABI change on std string come in, and somebody else is using that, then you end up having to put your own binary ABI layer on top of C++, normally a C interface, which just completely complicates everything, and it really that ruins you using all of the nice exotic C++20 template features, concepts and ranges and things like that you might be hoping to use, but now you've had to add this big layer of abstraction that stops you using any of that. So it's very company dependent.
Yeah, you're totally right. There are embedded companies which are fight with 11. There are embedded companies which hire me for C++20 class. So this is such difference, but they essentially produce the same products.
Let me move on. So Christian asked an interesting question. Is there any projects on quantum computing done in C++? So for example, the development of derivative pricing using this kind of technology. So I know, for instance, like GPUs are starting to be used a lot more. For instance, you could parallelize Monte Carlo. So especially when you're dealing with complex kind of exotic derivatives, is quite useful. So you're writing stuff in CUDA. What about quantum computing? The next big leap.
I have to say I don't know regarding C++ for this. I remember when I was at City, my old manager being flown out to NASA to see a talk on quantum computing, see the latest techniques, and they were looking at how they could use those. And that was back in about 2016. I don't know if things have changed since then. Certainly at that point, it wasn't a viable technology, and it was very useful for certain problems, big mathematical optimizations and certain things, but general logic, it was not nearly as good as a normal CPU. It's not something we're looking at in HFT, so I haven't looked at it in the last few years for sure.
There's a book I started to read, and I want to one day, well, maybe over Christmas, I'll get back to it on quantum computing. My take on it is that quantum computing is effectively a new and in some cases improved type of logic that to apply to problems that has been discovered through the research into quantum mechanics. And you know, it's a difficult thing to get your head around, and more difficult to apply it to actual problems. But from my understanding is there are problems that it can solve that you won't be able to solve as well using normal, you know, sort of mathematical logic. So it'll happen, and you know, it's good, you know. It's a new field that you have to learn, and it's, you know, you really have to study it. I haven't learned it properly. It's a good one to learn, people out there, you know, if you want to get into an area which is likely to be good in, it's going to give you big bucks in 15 years, then quantum computing. I'm getting a bit tired, guys. Don't know about you guys.
Yeah. Maybe we should wrap it up. Maybe shall I just finish with one question, and then
So I can see a lot of great questions there, I must say. Yeah.
But there's still a future for us. We can do it in another panel.
Yeah, that's right.
Yeah, well, it's worth saying we'll take these questions away, won't we, and try and find
Sure.
some form of answering them. So even if we don't answer them right now, we'll come back to answer these.
Okay, that's fine. Maybe we'll just wrap it up now then. Yeah, it has been quite a while. But, you know, thanks again, everyone. You know, Antony, Richard, Rainer, for your talks. That was really interesting. Always great to have you guys on. And thanks everyone who stayed till the end. You know, always quite a long one, but yeah, please do continue the conversation on Telegram, and there will be an exit kind of survey at the end. So, you know, it'd be great to get your feedback on the webinar and get just any opinions on how we can improve it in the future.
I should say, just one thing. Sorry, Jahan. We're going to have a series of webinars in the new year in which we do live algo trading, and in fact in Python. So we will. Well, we haven't worked out the topics yet, but we will, you know, actually demonstrate live algo trading, where, well, in theory, we'll actually do our best to make some money with it. No promises.
Yeah, so I guess we'll send more information about that, but there'll be kind of a series of webinars, but then we'll also have a course on that as well, which will be a lot more in depth and one-to-one. Okay, yeah, thanks a lot, guys, and yeah, it was really great having you all here, and yeah, we'll try and do this again, hopefully sometime in the year. But if we don't, you know, see everyone, all the best for Christmas and the New Year. And
Merry Christmas and Happy New Year, everyone. Yeah,
absolutely. Merry Christmas. Cheers.
Bye.
See you all soon.
Bye.
Bye.
Bye. Have a nice time.
Bye.